Hello, my name is Alan Clark. As a member of the SUSE office of the CTO, I've been engaged with the emerging market and technology area surrounding and for edge computing. SUSECON has some great presentations this year detailing the technology around edge computing. So I thought it would be interesting to take a few minutes and give a different perspective on edge computing. That perspective being on the data for edge computing. So to provide you a bit of perspective on what is edge computing, how the edge is rapidly moving, and the importance of the data at the edge, I wanted to use a simple example that we can all relate to and that hopefully helps you to understand the value of the data. So do you remember years ago when you acquired your first laptop? Isn't it funny how we used to consider our laptops as mobile devices, right? We thought they were out there on the edge. How it felt to be mobile, yet the challenges of being connected. The challenge is to take that information that we created on our laptops and sync that back to our desktop or back to a central office. At that time, the laptop felt like it was at the far edge of computing, particularly with it being networked. Now think about the mobile device that you're constantly carrying, that mobile phone. It's a sure bet that the number of applications and functions on that device has grown, not shrank, over the past couple of years. Now, I would proffer that many of the functions on that mobile device are functions that you used to do and perform on your laptop or back at your desk. Now, think about it. If you were to lose that mobile device right now, what would be your top reaction? Sure, you would moan about the loss of an expensive device, and they are expensive. But the real pain in question quickly comes to your mind. Have I lost my data? Devices can easily be replaced. They're expensive, but they can easily be replaced. But what about the data? That feeling or notion of data loss is why edge computing is really about the data and why it is the data that is of value for edge. But have you noticed lately how your mobile device isn't at the forefront of edge? Many of you are now using or carrying devices that are tied to your phone. Think about those smartwatches or data gathering devices such as biomonitors, smart monitors, heart rate sensors, or even things to do contactless payments. In particular, think about what those devices are doing. They are gathering data, but you're then using your mobile phone, your mobile device, to filter, store, and process that data. With the point that the mobile device is being used to analyze that data as close to the source as possible. Hence my point that the edge is moving. It's moving closer and closer to the data. Getting closer to the data is why edge keeps moving. Now, I'm sure you've seen many presentations that give a definition of edge computing, so I'm not going to do that here. They discuss where edge resides, where it stops or starts, and sometimes that can be a debated topic. But it's largely irrelevant to its definition. Within all those definitions, the essence of edge computing is to connect devices that can process data closer to where the data is being created. We want to shift thinking away from simply moving processing to the edge, which many of the definitions define and do. We want to think more about enabling target use cases by getting access to the data in the time and manner required. So what is important to note is that it is outside of traditional secure data center or cloud. That's where edge is, outside of those typical data centers. And that edge adheres to imperatives in a manner enabled to the desired use case. On the other hand, where the edge resides in a specific instance obviously does not matter to selecting technology for that specific deployment. In other words, specifically, it's not just about compute. Edge use cases require the full spectrum of IT technology, including storage, analytics, of course, connectivity, because we've got to capture and manage those data streams. Critical security, we have security in the news all the time, and governance controls. Now, edge computing is comprised of a collection of hardware and software. There's no single physical architecture that represents all implementations. Rather, physical hardware characteristics and its placement are based on the requirements of each specific use case. Implementations could be as simple as a gateway with some basic embedded analytical processing to support real-time feedback, to simple devices attached to a complex microdata center capable of supporting thousands of devices. It could be highly available with rich machine learning capabilities. So what does the data look like? Well, it looks like waffle fries. Chick-fil-A wrote a blog that I really liked back in 2018, and their hypothesis, quote, by making smarter kitchen equipment, we can collect more data. By applying data to our restaurant, we can build more intelligent systems. By building more intelligent systems, we can better scale our business. So they talked about how the cloud has been used to forecast their waffle fry needs by simply analyzing transaction sale data from the restaurants. What they found is that isn't accurate enough for their restaurants because their restaurants are doing greater than 3 times the volume that they were initially designed for. But by collecting keystrokes in real time, tying that with the work in progress inventory, and leveraging those initial sales forecasts, they gain a much better, more accurate picture of how many fries, waffle fries, and the other goods, of course, that they need to cook at any moment. So what does data look like? It looks like unstructured or semi-structured readings from sensors, actuators, and devices in manufacturing. Such data intake may be from a large number of devices or other data sources, and could be all at the same time. That data is generated with the intent to prevent machine shutdowns, to reduce risk, or to provide preemptive insights. Understanding that tells us that the challenge can be latency. As an example, breakdowns in automated manufacturing processes can cause significant downtime and loss of production. In these situations, any latency in the collection and analysis of the data and the triggering of the action can be very expensive. Here, machine solutions that allow instant near real-time warnings to the machines and the operators, or even preventive machine shutdowns, can reduce risks and costs much better than a cloud-based solution, which are prone to latency. Manufacturing is recognizing the need, desire, and ability to have a better understanding of how their production lines are operating, to make better predictions for servicing particular machines, and to reduce unpredicted downtime. It is a disruptive innovation as it radically changes business processes within and across that sector. A key mechanism of this disruption is the convergence between traditional IT, information technology, and OT, operation technology in production and logistics processes. Combining the real-time monitoring capabilities brings those technologies together. These applications gather sensor data, leveraging edge computing to refine and analyze the data forwarding the actionable information to distributed data centers in a time-sensitive manner. The sensors and edge nodes could encompass hundreds to thousands of individual endpoints in a deployment. Another example of what data looks like, it looks like consumer experience, or in other words, your my expectations. The retail industry is in a major state of change. Global events such as COVID-19 and consumer habits that are changing in these types of environments are forcing retail into the future. As the landscape evolves, the consumer experience is the key. Modern consumers value convenience, speed, and seamless experience. The ability to easily find products and a fast contactless checkout are key. If you're not delivering a convenient and seamless experience, you're going to lose customers. They will walk out your door or they're a click away from your website. In the retail space, edge computing is influencing mobile ordering ahead solutions, scan and go technology, curbside pickup, curbside delivery. So understanding what the data is and what it looks like then leads us to the critical steps in the data flow. At a recent Gaia X webinar, Gaia X, of course, is the European Initiative for Data Sovereignty. It was noted that 80% of the data being processed today is in the data center, 20% at the edge. But yet 5 years from now, it will be the reversal. Not because the data center amount is going down, but because the edge is going up. So we have an explosion of data generating endpoints from people, things, and businesses. The growth and scale of edge computing dictates the need for intelligent data ingestion and monitoring at a high scale. Ingesting all that data means that we've got to figure out how to store. Generated information comes in the form of structured and unstructured data. Storing relevant data is going to be imperative. Storage must be resilient, of course. Installation must entail a minimal local administration footprint and storage. And storage that can contain data from the block level up to the database level. All the gathered data from those various sources has got to be clean, converged, and secured. So depending upon the source and the style of the data gathered, not all of that data is of value. With the constraint for space at the edge and the combined networking bandwidth, it's imperative that the extraneous data be eliminated and the data be cataloged. The power of edge computing isn't just from a single point. The power is realized when data from the many points are converged and secured. Then the real power of edge is through the analysis of that data. Today and the future, our expectations as users are towards real-time analytics, including inferencing and learning. The real drive with the modeling and analysis is towards action. Then, of course, the data should flow to and from the edge to the distributed data centers and to the cloud. Leveraging, of course, things like the robustness of clustering, lifecycle mechanisms for provisioning, management, observability, and security. But remember, with all these data steps, the overarching goal for all of this data is to drive business action with real-world response and with precision. So edge computing isn't new. The possibilities with edge have dramatically changed. The advent of new technology enables the capture of new real-time action through that data. That's what's creating this huge market trend for edge computing. That's why we're seeing the hype today. So what's the trend and where's this market heading? Today's edge computing market is rapidly leveraging the latest technology as close as possible to the data source to be able to intelligently predict, act, and/or respond to that data in real time. But we're not done. We've gone from static insightfulness to responsiveness and with some intelligence, but there's much more intelligence that needs to happen. So we're not quite there yet. AI at the edge is still at the embryonic stage. It'll still be a couple years before we achieve that. But even once we've achieved AI at the edge, then we'll be able to begin to leverage these rich endpoints tied to multiple data centers and clouds in a continuous cooperative manner to build self-organizing applications. That's going to be a fun, exciting day, and I'm looking forward to it. Now, these examples and use cases I've given hopefully have started you thinking about some of the challenges that we have at the edge. We've talked about latency, right? The delay that it takes from getting the data from the endpoint back to the data center. Complexity, as we're gathering more and more endpoints, that builds complexity on how we manage, bring those into a consistent state. Then we've got issues with bandwidth. The more we scale up, the more bandwidth challenge we have. Oftentimes those edge devices are in a rugged space, right? They need to be resilient. They need to be autonomous. Then privacy becomes a concern. And of course, as I mentioned, we see security issues all the time in the news. Also out at the edge, we've got challenges around supportability and adaptability into that space. So as one looks at these use cases, a common architecture and a set of required capabilities becomes evident. The principal architecture description is a layered architecture. Typically, the layers break down the architecture from a central core to a cloud, to a regional distribution of data centers, to some type of aggregation edge, and then onto an access edge. Now, when you think about this architecture, be careful not to fall into the trap of delivering siloed solutions at the edge. That's been very tempting and very expedient because of things like COVID-19, where we needed to hurry and get out these new services. But that's a trap. So be careful in thinking about that. Instead, you need to develop a consistent, standardized infrastructure. The edge just doesn't exist in stationary isolation. Rather, edge is the enabling platform of a solution that necessarily connects many aspects of an enterprise ecosystem. It is important to view edge as a primary player with holistic solutions. Now, SUSE's thought much about this, and that's one of the reasons I believe why SUSE's vision is from the cloud to the data center to the edge. So I invite you to check out the other SUSECON edge computing presentations that are happening this week. They're going to delve into the technologies that will provide a holistic solution from the edge to the data center to the cloud. Thank you for your interest. Thank you for attending this session. I hope you enjoy SUSECON. I hope this has brought you a new appreciation for the value of the data at the edge. And I invite you to enjoy living on the edge. Cheers. Thank you.